Determine the limit as x approaches positive infinity and as x approaches negative infinity of x squared times sine of 1 over x. Starting with the limit as x approaches positive infinity of x squared sine of 1 over x, the first thing to do is plug a positive infinity in for each of the x's. Positive infinity squared will be positive infinity. And 1 over x will go to 0 as x approaches positive infinity, giving sine of 0. The sine of 0 is 0, giving positive infinity times 0. We have the infinity times 0 indeterminate form here. Since the 0 resulted from a sine of 0, we can make use of the identity limit as theta goes to 0 of sine of theta divided by theta equals to 1. Theta has to be going to 0. Theta is the phase of sine. It's 1 over x here. We have to phase match it with the other position. The sine's in the numerator, so we will need to phase match it in the denominator. So we have the limit as x approaches positive infinity of x squared. We will isolate the sine. We will now phase match it. We need a 1 over x in the denominator, and to compensate we'll put a 1 over x in the numerator. X squared times 1 over x, we can cancel one of the x's out, since 1 is in the numerator, 1 is in the denominator, leaving an x times a 1 in the numerator, so x, and sine of 1 over x over 1 over x. 1 over x is going to 0 as x approaches positive infinity, and it is phase matched, so this will have a limit of 1, and now we plug positive infinity in for any remaining x's, and that will give positive infinity times 1. Which is positive infinity. Now to work out the limit as x approaches negative infinity of x squared sine of 1 over x, the first thing to do is try plugging a negative infinity in for each of the x's. Negative infinity squared is also positive infinity times the sine of, and 1 over x goes to 0 as x approaches negative infinity, so sine of 0. The sine of 0 is 0, and we have the infinity times 0 indeterminate form here. We will have to rework this. Since it resulted from the sine of 0 making 0, we can make use of the same identity. We will isolate the sine. We will phase match it by putting it over 1 over x, compensate with 1 over x. One of the x's cancels. X times 1 is x. And sine of 1 over x over 1 over x. 1 over x does go to 0 as x approaches negative infinity, and it's perfectly phase matched, so this has the identity. We'll go to a 1. We can now plug in a negative infinity in for any remaining x's, which will give a negative infinity times 1. Negative infinity times 1 is negative infinity. And there's the results of the two different limits.